In our previous step, we have formed our two differential equation from our electrical part just by looking at this analogous table for our torque voltage analogy over there. And after I have looked at these two electrical equations, I have realized that these two equations do require some further modification in order to look at this expression as in terms of a voltage and current over there. And what is the exact step for that one? I have utilized our analogous chart over here, which is the angular displacement parameter is analogous with our charge. Now, if you do take the derivative on both sides with respect to time, we have got d theta by dt, which is equal to quite naturally dq2 by dt, and this is the exact definition for our current, which is our IT, because we do know that the current is ultimately the rate of change of charge with respect to time. And after we have got or rearranged our expression, we do know that the qt is ultimately our integration of it dt. So we have got these two relation over here. The first relation is dqt by dt, which is equal to it, and the second one is our qt is equal to our integration of our it dt. Now we are going to replace these two relation in our given two electrical equation, and let us see what is going to be the final form for our electrical equation. So just do for that one over here. So I should erase these two relations over there, and we do require further modification for these two electrical equation over here. And I can erase the mechanical differential equation over there, as we have already interchanged that into electrical part over there. So these two equations are no longer required for the present step over here. So if you do replace these two relation of dqt by dt, which is equal to it, and qt is equal to our integration of our it dt, if you do replace these two relation in our two electrical equation, what is going to be the equation? Let us do write down over here. So the first electrical equation will become our et is equal to our L1. This one should be our dit by dt plus 1 by c. The qt will be our integration of it dt. So inside our bracket I do have this one will be our it dt minus this one will be our I1t dt. For the next part we do have plus R12, and ddt of qt means our it. So instead of writing this as for our consideration, I can write it as it minus of our I1t. So after we have converted our equation 1a, the equation will turn into this one. So I have just utilized or replaced these two relation in our given equation, and after that the equation will be look like this one. So what we have considered over here, we have utilized that dqt by dt. I have replaced that with our it. So this one will be a ddt of our it, and this one will be 1 by c, and instead of writing this as our qt, I have written that qt is equal to integration of it dt. So I have written that it dt and I1t dt, and for this one we have written that R12 is equal to ddt of qt means our it. So this one will be our it minus of our I1t. So this is our first electrical equation over here, and in our next part for electrical equation we are just going to utilize or we are going to follow the same procedure over here. So this is our first electrical equation, and let us do the same for our next electrical equation as well. So for that one I can say that the second equation will be L2, this one will be our di1t by dt plus R ddt of q1t means our I1t plus 1 by c inside our bracket. Instead of writing this as our q1t, I should write it as integration of it dt. So this one will be our I1t dt minus this one will be our it dt. plus R12 dt of Q1t means our I1t minus ddt of Qt means our IT. Okay, this is equal to 0. So this is our second electrical equation over here. So I have just replaced these two relations in our current electrical equation, which are 1e and 2e, or which we have named as 1e and 2e over here, and I have replaced that into our current electrical equations of 1e and 2e over here. And after that, the two relations or the two electrical equations are look like these are our two electrical equations. So in our next part, we are going to form the electrical circuit diagram over here. So let us do concentrate on that portion over here. So we have got the voltage source over here. So just looking at these two given electrical equations, we have realized that the ET is been connected over here. So this is our ET, the voltage source of ET that is been connected over here, and the inductance will be considered as our considered point. So L1 will be there. The capacitor is placed, and the capacitor and the resistor are placed in between our two common parts for consideration. So this is our C, and this one will be our R12. So what is going to be the loop in this considered part over here? I should write the ET at the outer part for our circuit. So this is our ET. Now in this current loop, the current will be our IT. Why IT? Because if you do apply the KVL in this given current loop, we have got that the voltage drop across the inductor will be L1 and the ET will be there. And the common part is been considered as our C and R12 over here. And why do we consider this as our common part? Because ultimately the resultant current is IT minus of I1T for our capacitor also. And the resultant current through our resistor R1T is quite naturally IT minus of I1T. Because of that, we have drawn this part of our consideration. So just do the same procedure for our circuit 2 or the equation 2 as well. So this one should be our L2, and the resistor R will be placed over there. The resistor R will be placed over there, and in this current loop, the current will be our I1T. Okay. Now, what is the give and take, or what is the final take up to this problem over here? If you do apply the KVL, say this is our loop 1 and this is our loop 2 in this way. Now, if you do apply the KVL at our loop 1, we will definitely have the first equation or electrical equation 1 over here. So quite naturally, if you do check that whether our circuit is right or wrong, if you do apply the KVL in this given loop, we have got ET, the voltage drop across the inductor will be L1 d IT by dt, this one, and the capacitor and the resistor R12 are placed in between our two current elements of IT and I1T over here, and because of that, the capacitor and the resistor part are placed in between our common part of our IT and I1T over here, and because of that, the resultant current will be IT minus of I1T, and for that R12 also, the IT and the I1T, or the difference of these two factors, are considered over here. Now let us go to the next part of our equation. We have got the inductance L2 will be present over there, because we do know that the voltage drop across the inductor will be L2 d dt of I1T, because in this loop 2 the current is quite naturally our I1T. Similarly, for our resistor part also, we have got this one, because the voltage drop across the resistor will be RI1T, and the capacitor and the R1T are placed in between our two current elements of I1T and IT over there, and we have already included that over here. Now, quite naturally, if you do apply the KVL at the loop 1, we have totally got the first electrical equation, which we have considered as our 1E. Now if you do the same for our loop 2 as well, if you do apply the KVL at our loop 2, we have got, this is our second electrical equation over there. So this is our final torque voltage analogy diagram over here. I hope you have totally understood up to this one. If you still have any doubts, please let us know in the comment section for better understanding. Do like, do share our videos, and keep following our channel. And no other YouTube channel will like to give you this type of detailed analysis over there. And I repeat once again, no other YouTube channel will like to give you this type of detailed analysis over here. So what are you waiting for? Please do subscribe our channel, hit the bell icon for more updates, and stay tuned with the classes. If you still have any doubts, please let us know in the comment section for better understanding. Do like, do share our videos, and keep following our channel. And I can do feel, or I can realize that these problems are going to help you. So that's it. Thank you and goodbye.
If you like my video, so what are you waiting for? Please do subscribe my channel, hit the bell icon for more updates, and stay tuned to the channel. Thank you and goodbye.